So, are there any questions? Yes? Mm-hmm. Okay, then let's start with some screen sharing from you. Wo ist denn das? Sicherheit. Okay, now you should be able to share the screen. Okay. Okay. And you have compiled the QWT library already? Okay. Okay. Okay, and so first thing to try is just try it again. Because when you look into the folder, there are like different folders. There is debug release, and there are files for 64 and for 32-bit builds. One potential issue is that if you have copied accidentally the 32-bit library into the 64-bit folder, then it will not find the symbols. Yeah, you need this one. Debug. Yeah. No problem. And yeah, paste it inside. Yes. Okay, the file size changed, so it was not the same file. Do the same with the DLL file. That's generated by the compiler. So now just press on build. Erstellen. Yes, of course. Okie dokie. So then let's start the screen sharing from my end. Yes. Okay. Well, what have you changed? Just the Qt version, or? That should not be a problem. Nah, that should work. I mean, I can use a diff tool to see the relevant changes and then just copy them to a local copy that is unchanged. So that should not be a problem. Okay, so okay, so to test this implementation that we have written, ideally one would run it on two computers. Because on the same computer, as you remember last time, we have had to add some random packet drop and things like that to at least simulate what can happen on the real internet. But ideally, of course, one would want to have two computers and run it on two computers, and then communicate from one physical machine to another. Since I guess not everyone has two computers, I was thinking that a good thing to implement would be a very simple UDP packet proxy, which would allow us to receive packages on some test server, and I would run it on one of my servers, and then you could just send packages and receive them from that server. So the idea is that if you send from your computer packages at a given port, it would check from which port the packages came and send them back to a port with the number higher by 1, so that you can set up two sockets on, let's say, port 1234 and 1235, and then you would be able to send packages from one. So you would send packages from your computer to the server that would then reflect them to the port one number higher or one number lower, depending on from which port the data are coming. So this would allow you to test the mechanism using something external. And I think this will also be a good quick exercise in creating Qt UI, since we will want to create some user interface for that. So let's start with a new project. Select Qt widget application. Let's call it UDP ping. So first we will create a project that just allows us to send individual packages back and forth, and then we will make the project with the packet reflector that I just mentioned. So to test that, we first need such a small tool that will allow us to send and receive individual packages. Next, we need network. Okay, so we have the empty project. We can try to run it. Okay. So let's first create the UI. And since it's a small utility and does not need to be particularly sophisticated UI-wise, we'll just use the graphical editor to create a nice UI, since this is the fastest way to create a UI, I think. So we select the element and we can select the layout. We want a grid layout, since this is a good start. We'll add a line edit where we can enter the address where we want things that on which part we want to listen. Then we add some spacers. We will also need a button to open the port. So that first button open. We specify a port and then we just press open. Then we want some list widget where we will log all the packages that we receive. Can make the widget span a couple of columns, and at the very bottom we will add another label and 2 line edits, one with the address where we want to send the data to, and one with the actual data. Okay, so and we need the send button. This is called send. Button send. Okay, here we have our data. Here we will have the target, IP and port, and here local port. Did we give names to everything? Oh, we forgot. Okay, so here we need to also give names to those. Takes the local ls data, takes the data, and takes the remote. Okay, can check if this works. I mean, it must work, but it's always good to see how the UI looks in practice before proceeding. Okay, that looks good. So now we will need to add the relevant functionality to our new project. So first we add some signals, slots. Void on open, on send. Those are for the 2 buttons, and one for the socket when we get data. So on UDP data, then we'll need some with the UDP socket Q UDP UDP, and we need to include the header. Okay, that should be that. So let's now go to the UI part. Socket is equals null. A good reason to run the project once before starting to write code is that then it compiles the header, the UI, and then we get this auto-generated header file where we have already all our elements defined, so that here the IntelliSense works as it should. First, this slot on open. Send. Oops. On open, on send, and on UDP data. On UDP data. Okay. So for the open function, we will check if there already is a socket in case we press the button twice. I mean, we could also just disable the button after pressed, but here, since we want to be able to change the socket, why is that not working? That should be fine. UDP as typos everywhere. Close the socket and we make it delete as at the nearest opportunity. Okay, and here we will just create a new socket. Zack. Bind q host address localhost y takes the local text to int and then we need also to connect the socket. Ready read with onUDP data, and then in our onUDP data make a loop while socket bytes available tune talk datagram data is equals. So the UDP sockets are not usually operated with just read and write, because they can receive data from different endpoints. So here we always use the receive datagram function instead of just making read on it. Actually, I haven't tested what happens when you make read on it. I guess it will just return you empty data, or it might return you the data without telling you where they came from. But since we want later at least to know where they came from, we use the proper function, and that's also what the documentation says. Here in this example we will not use the other data available on our data object, but if we would want to know where the data came from, actually why not, let's add that. Why not? Data punct what was it? Send address to string data. Typing will be faster. Sender port. Make here our format, so %1, %2, %3. So we have IP double point port double point the data that we received, and here in on send we'll send. So first of all we will need to check if we actually have a socket, because we might not have one. So if we don't have a socket, then we just return, and we can show a message message box critical this title message text socket not opened. Okay, that's one thing. Then we need to check, first we need to get the text from our target label, target edit, y.txt remote text. Okay, pass 2 index of double point, second error message if pos is not found. So if pos is equals -1 of the ping invalid target. Okay, and now if we have this, new host address from 2.left pos and top part is equals to mid little t, to mid pos plus 1 to int and pass socket write datagram. We also don't use write, just write datagram, and here this is absolutely necessary because otherwise the thing would not know where to send the data. So UI punct text data text to UTF-8 encoding. So here we specify this explicitly, and port address and port, and voila, that's the simplest UDP test program we can come up with in a short time. Okay, so let's open port 1234. Let's now try to send something to... Okay, it's loading symbols, it's hanging, it needs a second or two. Okay, 127.0.0.1, so that's localhost. And let's send test, oops, works, nice. So now the next thing we'll do is we will create a new project called UDP relay, maybe. Yeah, that's a good name. Create new project. UDP relay create. Into this project we can copy and paste quite a few things from the other project so that it will be faster. Okay, we need of course network everywhere. Next, precompiled header finish. So first of all we will open this as a text file, since we don't want to waste time recreating the UI. I mean, we only need a portion of it, but we still can just copy and paste more or less the whole thing with UI, yeah, relay up to here, and okay, that should be right. Let's see if it works. And if it works, then we can, as the next step, start removing the few components we don't need for this UI. So this UI will only have a port to open and the message log, since we want to be able to see which packages were relayed from where to where. And for the message log, I will also add a checkbox such that we can disable it, since if we want to have some higher data rate, then we will not want every packet to be logged, because that would just limit our maximal possible data rate far too much. Okay, I apparently did not rename something that needed to be renamed, but it loaded it fine, so we get rid of this, we add a checkbox. Let's put it here. Checkbox chk log and a text checkbox log packets. Okay, and the idea how this will work is that if the port is even, then it will add one, and if the port is odd, then it will subtract one from the port number. So so you can set up on your local machine, for example, two clients using port 2 and 2 and 3, and then if you send from your computer something on package from the port 2, then it will be sent back to your computer to port 3. At least that is the plan. So let's see how quickly we can implement that. So for the header files, we will just copy most things. I mean, we pretty much copy everything except we don't need the send button, since the proxy does not have the send button. On the ping. Yes? They will be received by the relay, and then they will be sent back to the address from where they came, but with a port either increased or decreased by 1. So the idea is that you can open 2 independent sockets on your computer, and they need to have different ports. And then the idea is that when you send something from one of the sockets to the relay, you will receive it on the other socket on your computer. I deleted the wrong block of code. Now it's the right one. Okay, so open is identical. There are no changes with regard to this, and we will only change our oh, we need one include. We'll only change the code for this thingy. Okay, so we have this. So if UI punct is checked. So if it is checked, then we log it, otherwise we don't. And here we need to send the package back from more or less where it came. And let's add, okay, wait, I forgot something. Here we need to check if this is valid, and if is valid, if it's not valid, then continue. And I will add the same thing here. Okay, now int port. I mean, technically we should use int16 for the port and not an integer, but meh. Data punct send port. Okay, so here then we need to modify the port. So if port modulo 2 is not null, then port plus plus, and else port minus minus. Okay, now per socket write datagram, data comma data punct sender address comma port. Okie dokie. Yeah, that's that. This is all. Let's run it. Then we will need our UDP ping. We actually need 2 UDP pings. So we can run it, and we can go to debug, detach. Okay, it's not yet fully debugging. Detach all, and then we can start it again. Haha. So we get 2 instances of our UDP ping. Why is the relay not running? Okay, the relay is still loading symbols. Well, we have our 2. Oh, sorry, that thing is called UDP relay. That's a small bug. TTT. We want to rename that. Oh, so relay is fine. Why did it set then that it's ping? No, it's fine, everything's fine. The ping, debug, detach all. Okay, now we have what we wanted. Okay, so relay, let's set up on port 1, 2, 3, 4. Open, log packets. The two pings. The one, let's go to 1, 2, 3, 5. The other two, 1, 2, 3, 6. Then we will try to send here to 1, 2, 3, 4. And to receive it here. And here, if we do the same thing, if we send it back, then we receive it here. Et voila, it's working. So now the next step would be to run the relay on the server. So let's quickly try that. I will just set it up remotely, and we will see whether that works as it should, or if there is an issue with that. Okay, so release period. Okay. 1, 2, 3, 4. Log packets, open. We will need some port forwarding most certainly. Intel test UDP 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 7, 0, 0, 1. Okay. Now we need to know the IP address of our test thingy. Okay. Okay, so we can close this thing and use the server's IP address. And it does not work. Why? I guess there is a firewall somewhere in the way. Windows Verwaltung. Firewall. Inbound rule, new rule. Port, next, UDP 1, 2, 3, 4. Next, Verbindung zulassen von überall. Test. Okay, let's try again. Okay, that is also not working, not good. Well, the port is open where it should be. The IP address should also be right. But it is not working. I will quickly try the same thing just from the host. Okay. That is not good. I'm not sure why this is not working as it should. Apparently some network configuration is not yet correct. Let's test again. So we have here the port forwarding set up 1234 1234 to local host. Yes, this is working as well, and we have the right firewall rule for the incoming connections to allow everything on port 1234. Remote ports, all ports. That is not great. So let's see here. We have at least sending packages. There are more firewalls. The sender side. Ping. Is that not? There are a couple of issues. Okay, so we need to change a few things before this will be working. With the relay and probably with the test client. I set this up here for localhost, but we don't want localhost, we want any. We want any address. And here we need to make the same fix. Okay. So let's start our ping again. And then we need to redeploy it to our server. One, two, three, four. Log package open. Debug, detach all, play. One, two, three, four. Oops, 1, 0, 1, 2, 3, 5. 1, 2, 3, 6. Open. Zugriff zulassen. Okay, both should be open. Okay, that was better, but not good enough. So I received it on the server, but it did not relay. Wait. Huh? Why am I getting the same package back? Oh, that's not good. That is not good. So what we are getting is the NAT is changing the port. So when we send data here from port 1235, we get the data arriving from a different port. This is not what we want. That might be a problem for you for the testing as well, because we do not get deterministic ports. So I can locally fix that by setting up some more net routing. Test 1. 1 2 3 5 1 2 3 5 10 70 10 what was the IP locally? 29 29. Okay, and test 2. Test 2 UDP 1236 1236 1070 1029. Test 1 UDP test 2. Now they should be set correctly. Let's see. Nope. It still picks a random port. What's the setting here? Bridge. Okay, this is correct. How do we fix that? That is not easy to fix. So basically, this will not work if you don't have a direct internet connection but are behind a NAT. That's a pity. I mean, we could of course send the data back to the same port from which the data came. Yeah, I guess that's the easiest quick fix we can apply. So let's do that. So this will complicate things slightly because we won't be able to use two applications at the same time unless we make like yet another layer of relaying. Okay, so we will just comment out our ports, build the relay again and deploy it again to the server. Okay. That ping. Okay, that kinda works, but for some reason we are getting the data multiple times. Why? So for every package we send, we get three times a notification. But the relay is relaying it only once back, so this part seems to be working fine. Oops. So it's something on our end. So we write a datagram, and then let's see how often we get the the event here. 1 2. Well, okay, that's not the best test. We need to be below the loop for it to work. So it was invoked twice. That is not not quite right. Well, that should work with ready read. And is the I mean we only sent it once. That should be okay. Now it was only once, so maybe the problem is with the inner loop that we should just invoke. What want this one? Okay, we send it once, we get one signal, and then we get a second signal. No, so we got two signals, and also in the loop we for some reason got the data twice. This was only connected once. Yeah, that should be fine. It is not. Well, that is slightly a problem, but at least the relay works as it should. It only relays once. So we could use that with the rest of our setup for testing. So let's do that, since this test ping was only needed to initially check whether we can send and receive packages. Right, datagram, but that should be. I mean, I would suppose that this might not work correctly, but we should not be able to receive more datagrams than what we have received, and we should only receive the datagrams that we send out. So I'm not sure why this thing is not working properly here. Let's try again, maybe we can find out what's the problem. Open, send. Okay, so we get one proper, so first here we somehow get the package reflected back to us, and then we get the package twice from the other end. Let's try a different port. Maybe we screwed up something with the routing. Okay, using a different port already improved the. It might also be a network issue that I set up somewhere the relay such that we get replicated packages. Let's try a completely different port, one that we haven't used yet, because I don't think the problem is with our code directly. Okay, 2, and how many we get here? Okay, well the on the receiving side we really get once, but for some reason the packet comes in twice. That is strange, but at this point I would say that we really get the packet twice. I mean, we can of course debug that properly and see what's happening on the network. Wireshark. Download, installer. So this tool can be used to monitor the whole network traffic on a given machine, and with it we should be able to see whether we really get the package coming in twice. And if we do, then it's annoying, but it's something that in principle we could ignore. We would then need to investigate further to find out where where this issue occurs. So we could try to find out, so install the Wireshark on the routing computer and then see whether it then generates the double packages or whether they came in already doubled from somewhere. But that doesn't matter that much, since our protocol is capable of handling repeated packages, so that should work fine enough. Well, finish Wireshark. Ethernet 0 is, I guess, the right one. And we will want to add a filter. How was that? Okay. Why is that not? How do I select the here? But that should now filter only to those where the port is 1, 2, 3, 4, but it's not. The filters are filtering. That is annoying. Why isn't it filtering? No, I don't think it enabled it. No, it's enabled, but it's still not filtering. It says it should be. Now. Okay, one moment, please. They changed too much in the new UI of this program. I'll just install the old version I know how to use. Program and feature. Was it Wireshark? Software. Uninstall everything. Okay. Don't want that. I think that's still too new. 32 new. That must be working properly. Okay. Did I not save it? Yeah, no, I think it's here. Okay. Nice. Okay, so now we have only the packages from the right pot. And now if we send something, yep, we are getting it twice. So we send it out, it goes out, and then it comes back in twice. Why? I would say we just ignore the issue, since it's probably not easy to find out what's happening there. I will just try one thing. I will turn off the port relay I set up earlier. Maybe that's the problem. Nope. It just happens again. Yeah, we have some package repeat. What we could try is I could upload the ping tool to the Moodle right now, and one of you can try sending a package and seeing whether it comes back in correct or whether it comes back, well, two of them. So let's try this. Ping, the ping. Actually, I could just pack both of them and then unzip. Okay, we cannot zip it while it's still open. That is not great. Maybe 7-zip is more tolerant. Okay, like with WinRAR, you can just say that you don't care. Yeah, and here it's also more tolerant. It just ignores whatever it cannot compress. Okay, what do we don't need? We don't need this. And we don't need this. And we don't need this. Okay. Okay, so let's see. Course. We want Bearbeitung, new file. Okay, the UDP ping pong is uploaded to Moodle. If one of you could download it, compile the ping project, and then send a test package to the address I will send in the chat. There's the chat of the Zoom. We will see, and then let us know whether it comes back correctly or whether we get back two packages like before. Any volunteers? Okay. So you need to enter some port and press open it in the top line, like 1, 2, 3, 4 open, and then in the bottom line you first enter the IP that I sent in the Zoom chat, and then you enter some text that will be sent. Yes. Well, we want to test the server, so that's the IP address of my server. So you only got to back one package, not two. Okay, so something screwed up with my network setup here, but that's good to know. That at least this part is working correctly. So now we are not all the way done yet, because if we would want to, so now what we can get packages back, but only on the same port. We send them through the internet, but this does not help us much with regard to creating some sort of traffic that we might want to have between two ports of our own computer. So what we could do is that we make another relay project, one which will relay the packages. So one that opens two UDP ports will receive packages on one port, send them to our reflection server, receive them back, and then send them out to on another port. Yeah, we can implement that, I guess. That is, or we can add an additional function to our current relay. So how would that? So the idea generally would be something like this. So we have where did I put the notepad now? So we would have three parties to our communication. One. And so we have two clients that we want to relay the communication of. Then we have here the local relay, remote relay. So the remote relay is on the server, the local relay will be on the local computer, and then it will work something like this. Client 1 sends a package to the, okay, let's do it like this, to the local relay. The local relay sends package to the remote relay, which will send it back to the local relay at the same port, and then the local relay will relay it Okay, let's to client 2, and then if client 2 sends something out to the local relay again sends it out, and then here. So that will be the plan. Well, it's not as pretty as only having one relay, but if we need a local relay, then we need it. And we want the communication through the internet to have realistic latencies and stuff like that. So how do we implement this best? Because one thing that will be a bit problematic is that when when the local relay receives this package coming in, it will need to know to where locally it's sent. This complicates things. But we'll add the functionality here to the relay we have. So we can so we will want to have more local ports. Yeah. Well, or we add that will be also an option to make this more flexible. That we can add as many relays as we want. Let's do it maybe this way. So here we add a button. So we add a button called button N. Add relay. Okay. And the button will add additional relays, which we will then be able to configure to work individually. So yeah, and every relay will require a couple of own elements. Add yeah, okay, let's well, this is not the prettiest implementation, but I mean, in principle, we should maybe should we get rid of that? That will be for the local relay, and for the other relay. I don't want to make this too complicated, because making this too complicated will just waste time for us, and we just want to be able to do some testing. I mean, the simpler way is we just hard code it without a UI. We just make the relay do whatever we want here. Yeah, let's go with this. So we'll comment out what we don't need. Socket 1. Wait, we need 2 sockets and 1 socket to communicate with the other side. Okay, so we need this socket 1, socket 2. Okay, we will open locally a socket and then always send back the same port where it came from. Okay, so maybe we will make a UI. I will just add more line edits for more ports. So here will be txt port 1, txt port 2, and this thing will be, we'll say remote relay IP port. But this makes this a new project. So let's make a copy of this. Well, we already have it zipped, so let's leave it as is. So here we will enter the remote relays IP and port, and here we'll enter 2 local IPs and ports. This should then take the. I will rename this to relay, and then you need just to press open to start the whole thing operating. Okay, that sounds like a plan. Okay, so we have here our sockets and on UDP data. We don't need more, so we need to copy something from our ping here, this part. So if we press open, okay, and here we will make an error message that it is already open. So if you want to reset it, you will just need to wait. Let's do it better. We'll just disable the open button once we're done. UI btn open set set enabled. So once we pressed it once, it cannot be pressed again. This was relay. Now let's stick with 2. The ping invalid tag invalid relay. Okay. For the relay we need to save those data. So cool. Relay IP. Relay IP and intersecting relay port. And there's one more thing. Locally, when we open a socket, we can, in principle, here skip the binding. Just select any address, and then it will select a port randomly for us. And for the outgoing port, which we'll use to communicate to the remote relay, we don't want to specify a port, so we don't do that. But we need to open the 2 other ports. So here we had how did we call that? Port 1 and port 2. Okay, so takes the 1 port 2, and we also need to rename socket. So socket 1, socket 1, socket 1, socket 2, socket 2, socket 2. Okay. Principle, we could also set UI, how do we call it? Takes the relay, set text, and I can hardcode our address. Okay, and I also could probably do the same thing for those, such that it does not need to be re-entered each time. We restart, so 1 and 2. Set text 1, 2, 3, 5, and 1, 2, 3, 6. Okay, so we open all the ports. Then we have here our data, and depending on from where, so if sender, so sender in this case is the object which has is issued this signal, so it will be either socket or one of the other ones. Oops. Okay, so if it's the socket, then it's an incoming package. Then we will relay it to socket 2. Wait, will that work as expected? No, it will not, because when we receive the package remotely, we will not know to where to relay it. Because what we want to do is really a bridge such that we can relay packages in both directions. But this way, it will not work properly, because we'll only be able to we will be able to relay packages through this bridge, but when we receive them back from the bridge, we don't know to which of the two ports we should send the package. That's a problem, and I think there is not really an truly elegant solution for that. No, there is. We just need two outgoing sockets. Instead of having one socket that sends the data out, we'll have two. And then based on this, we will be able to decide where to relay the data. Yep. That's a plan. That is a plan. So we change here. We'll have socket 1 in and out, 2 in and 2 out. Okay. So here in the in socket, we should not call it in and out. We should call it local and remote. Yeah. Okay, so the local socket needs to have the port set. The remote one doesn't. Local but we need bind, we just need it without the port. Okay, and here okay, so we have our local remote ports, port 1, port 2. So now if if we receive data on local L1, then we use actually we could make it like this, that we make here a temporary variable okay, so if we receive the data on socket 1 local, then we want to send it out on socket 1 remote, and if we receive it on socket 2 local, then we want to send it out on socket 2 remote. and if we get it at socket 1 remote, then we will want to use our socket 1 local to send the package out. Is that correct? So let's see. We receive data on 1. We send it out on R. We receive it from R. No, and then we want to relay it to 2 local. And then the other way around, we receive some. Okay, and the other way, we'll then just swap 1 and 2 to 1. That is almost right. We are missing a few things. To send the packets, we need to know where to know the port where to send them to. So we will need to add 1 and port 1 and 2 and port 2. Okay. Now here finally, okay, we need also the address here. But we only need it conditionally. Okay, so if you receive it on R1, then the address to send it to will be M address relay address, and the port will be the relay port. And if we so R1 and R1, so this is here the same, but if we are now in this case, we will want to have address let's say address 2. It's up to us to define which one is 1 and which one is 2, so we just need to be consistent. 1 and 1, okay. So if just in case this or else here else return. So we know that if we continue to the code below, one of the cases happens. Actually, we don't even need to initialize this here. Okay, now we will replace this and we will just send the datagram. Do we want to log it? We might want to log it to socket data, and here we have our okay. But we will need a few more things. So okay, so if we have the if we receive a package on our local 1 address, then we'll need to modify to store the address. So wait, okay. I really hope I don't screw this up, because this is quite wasteful in time to debug. Okay, so let's think about it. We start with our ping thingy. From the ping thingy, we send a package to our local thing on port L1, which then sends this out on R1 towards the relay. The relay relays it back, so we get the package back on R1. And the way the relay works is it is in the end supposed to relay it to our L2 port to the second client. Okay, and the other direction, if works here as well, we've received on L2, we now use R2 and receive it to L1. This is almost correct. The one major issue is that we do not know at this point which address that would be. So actually, instead of trying to track the addresses and ports, we'll just make a UI entry to hardcode it. This is probably the better solution. So here we have the local port. I probably will need labels so that it is clear what is what. So here here we have the next label. Okay, let's be more descriptive. Relay input 1. Okay, we don't have enough space. 1. This is the port that the client 1 has to talk to. Client 1 target port. And here will be client 1's own port. Okay, and then the same thing for client 2. Client 2's own port. Client 1 that's a nice more short. Okay, so these were called port 1. And let's stay with _2. I don't have an idea of a better name, but this will be port 2 _2. Okay. So relay is fine. And if it's from R2, then we need to get UI punct. Okay, address we don't need. Cool. Oops. Just define that this should be localhost. And here UI takes the port 22 text to string twint. And here will be port 12. Okay, and then we just write the package to there. We don't need anything else here. And we log it. Okay, that should work. So let's start this. Oops, something's wrong. Yes, we don't have this variable anymore. Wait, we could here pre-fill the other ones as well. Okay, so let's see this to communicate 5, 6, 7, and 8. Yeah. Ping this one. so we open this, we log package, we open the thing, we allow it network access. So we need those two ports for our two thingies. Open it, open. Now we want here, we'll send to port 2, so here 12701 and it doesn't work. We send here, so this should be received by this port, and then it should be relayed to client 1. Okay. DP relay socket ping. Huh? It's not receiving the data at all. Why? LR read port 1 any, port 2 for the remote we can take any, that should be fine. Okay, so relay sockets. 5 and 7. 5 and 7, that is correct. Okay. So why don't, let's just reopen those and try again. Okay, let's try again. So relay. I pressed open, yes, so this should be working. Socket. It opened the sockets. The breakpoint. Let's try the ping again. Um, 1, 2, 3, 4. Sorry. Don't want 4. We want 6. 6. 1, 2, 3. Wait. 127 001 Doppelpunkt. So this is the 6th one, then it should for client 1 should be 1, 2, 3, 5. Test. Okay, open socket. Okay, this works. So we get this. Then we relay it, then we are not getting the package back. IP relay port Y. Okay, so first of all, let's see on the other end if we get the package. So this is working. So send. Okay, something's breaking because it here is no longer. You only can like trigger one event and then okay, really send. Oh, no, it didn't work either. We need to open it first. Okay, log package and send. Okay, one package comes in, but it's not being sent out. And it breaks. I know why. that was a mistake. We use the same socket then to receive, which of course does not work. Let's call this out. Oops. And socket out is this one, data. Okay. Now it should work, I hope. Okay, but since I'm optimistic that it will work, we go here on ping, debug, detach all, and start the second ping instance. So we can start our relay, we can log packages. Here for the ping instance, data port is 11238. Okay, this is open. Well, we got quite a few packages, but it's working. Here, if we send it back to 7. Interesting. Yeah. Okay, so is this working as we wanted? Because we will be. So if we are here, we will just talk to this port all the time, and we will receive data from this port all the time. Should be working. Let's turn off packet logging on the server as well, and now try this thing. Let's try it. We need to close this since we need the ports to be available again. Wait, maybe one more thing to test before we quit. One moment please, I need to check something. Okay, let's continue testing. So, what was it? Ping debug. So local port was 1236. Open. Okay. Let's think. So this will be the address we are talking to. And if we receive a package, that should be working. Let's try it. Just try it. So where do we have our server? Client server. So we'll be listening on the first part. 1, 2. Sorry, client thoughts. 1, 2, 3, 6. 2, 3, 6. We'll be listening at, and then client, which connects, should then connect to localhost to, well, well, not 1, 2, 6, because this is wrong. Port for client, this port. So if we send the connection request to this port, it should come out here. Yeah, let's try it. So connect. Sends our send to send. So we put just a breakpoint here to see if we receive it. And let's log the packages so that we see that what's happening. Of course, the connection will yet not fully be established because we have not made all the provisions for the other direction of communication. But at least we should see if we can get one package through the network through our relay. Okay, run test, and well, it sent data, but we did not get them. Why? So it receives packages. 1, 2, 3, 4. We try to connect. Let's go back over here. Let's restart this. Socket address. Wait, why do we already now make a connect? It should only start connecting when we press the other button. This should be the right thing, so we get one package in. Okay. Well, it sent the package, and then it should have sent the package out on... I think it's the wrong port. We set up the 6 before, right? Server... We set up the 6. Yeah, okay, that is not how it's supposed to work. So let's send it on port 7. Then we should get it on the other way, on the other port in. Can we send it? And we get it in. Yes. So this works, of course. What is now missing is a back channel. The back channel is not yet working. Okay, so when we get the sync package, we create a new socket. So listen is this thing, this is okay. Listen the port and then the other one send to connect to the socket. So we have the send to M socket. So the socket should already be created at this moment. I think this was in the constructor somewhere. Yeah, so here we create a socket, the other socket. So what we will want to do is we will want to be able to say which port the other communication direction should use. So let's add here the ability to specify a port. Not port with socket. We have a create somewhere else. Okay, that is of course not great because the listener already takes the port. Then we do the bind. Okay, let's just add not listen, but bind. Let's just add a bind function. That's better. Okay, bind will just do this. So okay, so now when we create the socket, the client side, so here is our client. Yep, we will be able to specify the other port we want it to use, and we want it to use the port for client, so we want this port. Yes, so we are talking to, so we sorry, need to say we bind it to this. Okay, so we bind to our port with the 6 at the end, then we connect, or we try to connect to the 7 one, which is here, which communication should go out. I think we need to connect to 8. Bind to 8. And where were we listening? Yes, we were listening on 6 and we need to bind to 8. Okay, let's try. That should now relay. So we have quite a lot of packet relaying, but I hope that this will allow for more realistic testing of the protocol. It's doing something. It gets a lot of unexpected packages, obviously, but it's working. We are communicating through the server. So if you look here, it's logging the packages that are sent, but it's not really working very well, as we have a lot of redundant packages, which is not good. but at least it works to the extent that we can use this to test things. Now we have another problem that the buffer went full, so okay, so since this thing is partially working now, any questions at this point to this relay mechanism? Mm-hmm. So if you want to use both or just one of them? Okay, so ping. We don't have the other ping now. Ping. No, that's not a problem. I have here a copy. It just needs a second to start. So okay, maybe it needs 2 seconds to start. It's already opened here. So in the first thing that should read relay, not ping. You just enter a port on which you want it to listen. So let's say 1, 2, 3, 4. Then you can select to log package and you press open. And then you probably will get a prompt from your firewall whether you want to allow it or not. And then in the other window, local port, it must be different. So let's see, for example, 1, 2, 3, 5. You open this, and then you can communicate to it with 1, 2, 7, 0, 0, 1, 1, 2, 3, 4. Then you can add the text. That cannot work in this case. What was the address? 1070 10 2, I think. Yeah. So I needed to enter the other computer since one is in the virtual. So this one is in the virtual machine. This one is outside. But if it would be on the same computer, then you could use the local host address and it would work. Mm-hmm. That's not good. You should get a result. Oh wait, that's interesting. Why am I getting a result here? It should no, sorry, it's fine, it's fine. It always so the way it works is it sends a package to the other one, then the other one logs it and sends it back. Sends it back. So you either get a result on both or on none, unless something's really strangely broken. Do you want to share screen and try to debug the issue? Okay, then I'll stop my screen sharing. Now you can share your screen. Okay, but you need to enter your own IP address or the local host address. Try 127.0.0.1. Yeah, now press send. Almost. It's not coming back. Why is it not coming back? You should get the package coming back to you as well. Can you restart the UDP ping? Just restart both of them, maybe. Okay, then configure them. Mm-hmm. Yeah. You forgot point 1. Yes, you need to open both, otherwise it will not work. Okay, then try something else. Change your local port to something else than 1235 at the top. Then press open again. Why isn't that coming back? Yes, yes, the port is right and it's open and it's working. But for some reason you don't get the package back. Open the project for the relay and go to the main file. Yeah, here and then source files and then UDP relay. Okay, and scroll down. You need to comment. You need to comment out line 39 until 42. Because here we are changing the ports, and that would be nice if we could run it on the server, but because of the NAT in the way, it will not work properly. But well, and now it should work as it should. Okay. Okay. Any more questions? Okay. So if there are no more questions, yeah, we are spamming this full of data. So there seem to be a few issues in our UMTCP implementation that will need to be also investigated. So one of them is that we get a buffer error at some point. Let's see here. Okay, so we start debugging, but it's always sending the packages all the time. So you can see if we just let it run without any changes, at some point it will start complaining that the buffer is full. So now it should be still working. It should be doing things. Where is that? Client, test client. Yeah, it's okay. It's not doing anything. Why? Okay, no, it's sending all the data all the time, and now at some point it says both are full after sending some amount of packets, and the question is why. So it should not store. We should all the time be able to receive data on the server side here, where we here we are receiving the data all the time. So we should not run in a situation that at some point the buffer will be full permanently, but it seems to be. So let's try to debug this. So the final homework will be to use this user mode TCP class to create an application to send and receive files. So the idea is that you open the two instances of the application, somewhat, I mean, on a very simple level, like with this ping thing. You open two of those pings. We can actually do that with the ping even. So we can open ping. Then we disconnect, debug, detach all, debug, start again. 1 1 2 3 4 1 1 2 3 5. Open. 3 5. And now basically the way this works is that on one of them, as you know, you enter something and then it just sends it to the other thing. But what we want, the tool that will need to be written as the final project, is that you, you start it, you enter a port, you press open, and then instead of typing data, you select a file. So we make a button that will open a file input dialog from Qt. That is quite easy to do. There is this Q file. What was the Q file dialog? It's more or less like one single line. There's one of this a static function somewhere. Static get. No, we don't want a file. Get open file name. Yeah, just get open file name, and this will open you the standard Windows file open dialog. Where is an example of that? Somewhere. Well, Google showed an example, although that was for a different platform. It just opens you this really normal dialog like this one, and then you select the file, and then it returns to you the file name of the file that was selected, and then you just and on another tool you press send, and then the idea is that it will read the file from front to back and send it in through the connection to the other end. So you will need to set up probably some handshake protocol that it will tell the other end what the file name should be. Or it could also be made like this, that you just start sending the file and the other client then just pops up a dialog, a file incoming, where to save it, and then you just press save. So well, the idea is that you use this user mode TCP, so you can, so since this is a data stream, you can reliably communicate data from one to another. So it should work like this: you send some message from the sender to the receiver that will say I want to send you a file named such and such. And so actually we could write this down as a small protocol specification maybe. And then at the end you will just stream the file, yes. So create project, widget, next, file streamer, create. This is so slow sometimes. We need network here as well. Next, precompiled header, finish. We need some sort of handshake protocol. Although it could also be made without the protocol. You could make it such that you open a connection and you send data, and this will just save the file into a file1.dat, file2.dat, and that's it. But that would be not very pretty. So Sorry again. No, we want to work with binary files which may contain the null character. So the idea would be that ideally you would communicate how large the file is, and then you would know how much to expect. So let's say here we have the sender side, here we have the receiver side, then we have somewhere in the middle vertical bar. Yeah. So the sender will first send a package, something that contains file offer. Then the receiver can answer. Let's make it like this. Then the receiver can answer on this with offer accept, which means that it wants to receive, it wants the file, or it can also answer with offer reject, which means it doesn't want the file. So if in the reject case, the sender closes the communication and nothing more happens. When the sender accepts, then you start sending the payload file data, and then you send just file data, send just one huge package with the file data, and pretty much that could be already it. And when you are done, you can close the connection, and the other end will then do the same. So actually it can be quite simple. And the package format for file offer would be something, could be something like let's always start with some size. So 132 size. So this is the size of the whole package which we are sending. Then you have so package size, we could also start with an opcode that identifies the package, but let's start with size. Package size, then we have 132 package opcode, and then as the payload you have Win64 file size. Then you have a let's say chat array file name, and the file name length would basically be just until the end of the package, or you could also have a terminating null, but you know that you always need to read the whole package size in order to process it. And the next, so offer accept would look like this. So we always have package size even if the size is just 8. Here we have package opcode, and this will be different. So this will be equals, let's say 1. This one will be equals, so let's say accept is 2, reject is 3, and in this case here size is equals 4, the below case as well, and in the top case it's equals 4 plus 8 plus len of file name plus 1, because we want the terminating null to be included in the string just in case. And then we have the file data package, which, so all the packages always start out the same with the same header. So this will be 4. Let's call them like this, nullx null, to make it look. You could of course change, so this is just a suggestion of a simple implementation. You could also change opcode to only be uint8 maybe. then you would save space. So this wait, 4 is not correct. It is 4 plus 4. Yeah, that's correct. Okay, so file data is 4 plus 4 and plus file size. File size. Well, it is a streaming connection, so you know that your accept and reject. Where do we have reject? If you accept, it will just send you the so it sends you the file offer. So you have the file size, so you know how large the file will be, and you know the file name. And then you either accept or reject, and then you can close the connection, or the other side is supposed to close the connection. Ideally, you would make it such that the other side closes the connection, but you will check if it tries to send you the file, despite of reject, that you then close the connection from your end. And then the other side, if it receives the accept, it will then send a file data package, which will be very large, containing the whole file payload. And since it's a streaming connection, you don't need to have file IDs in every package, because you know the context. No, because you know the context. So you know that within this stream of communication, you were offered this file, so your accept represents that file. And that's that. So that would be one suggestion of how this could look. And what we also could look is, for example, the header. So stoked as header. I don't think you want it defined, so okay. Stoked as offer. Stoked as offer contains header, and then it contains signal in 64 file size, and then it contains file name as a open-ended array. And for offer and accept, you don't need their own structure, because there you don't care. You just use header and set size and opcode. And for the file data, it would be, of course, best if you would save the file data to the file as you receive it. So in this case, you would also just go with reading the header, and then just streaming the file data through the connection. So we don't need an explicit package for this as well. I think there was a question. This one? This is this. Because it's 64-bit. Well, 64 divided by 8 is 8. So it's if it's a 64-bit integer, you have 8 byte that it will take of space. Okay, so let's say example. Okay, so let's summarize the task, since we only have a few minutes left. So final project homework. think okay. Um, yeah, should we accept by default? I would say probably yes. Or we can make an option. The receiver should check if so to the receive directory dialog should be denied. The file maybe it's the file transfer should be rejected. Okay. So this is basically the basic functionality. So by elements one no, first is port entry listening entry edit listening button 2 3 okay for a STU widget okay, and then for the sending 5 first a receiver IP port enter edit box with a to send a file. Yeah, so these are them. Yeah, okay. Let's change that slightly. So this will be point 4 and the list box is 5. A list view containing list of received send and of send received file, so that we have a list. If you send something, you send it, and if you receive it, you send it as well. List file name, comma size, comma transfer duration, so that we know how long it took to send the file. Name, sender IP port, size Okay, let's start with this file name and size, then sender IP port, and then duration, so that we know from whom we have received the file. And this will be the basic functionality. And now to the optional functionalities. Optional function. Optional. How did we call it? CUM TCP. Was it this? Was it just UMTCP? No, it was just UMTCP. So using ATCP QTCP instead of a custom TCP. Therefore, a Q abstract for okay. At okay, so the idea here is that you can create a class derived from QAbstract socket, which would provide the same Qt style interface for our C user mode TCP class, such that then if you just operate using a QAbstract socket for the most part, you can use the same code for both and then easily switch between both protocols. Of course, you need to set up the same protocol on the sender and receiver, obviously, but other than that, it should avoid unnecessary complications in the code. So it will not be like that you have two cases, one for user mode TCP, one for the normal TCP everywhere, but you really probably only have the case where you create the socket and maybe when you are connecting it, and the rest of the communication should work directly using the read and write functions as provided by the QAbstract socket. Okay, this will be one option, I think. And another optional thing would be add a for that create a new plot for every file. Yes, okay, one more thing to add here to the main specification. Okay, that's a bit too long. Okay, so the thing must be asynchronous in the sense that you tell it send file, and as soon as you are done with the dialog, you can now enter another IP address, select another file, and send the next file, and so on and so on and so on. And here, of course, when we add the graph, if you decide to add the graph, then this will be interesting because like you will get being star. A graph for every single file that is being transferred. I think that is quite nice. And we should add a sixth control element here and a clear button for the list. In Klammern, it should not are still in progress transfers. So it should only clean up the files that have already been completed sending and receiving. Okay, optional. I guess this is already good enough. So this will be a good exercise in abstract classes. This will be a nice QVT. And if you want, there is a third optional thing. I add a rate limiting can be rate control side it's like optional because on the receiver side rate control is a mess because you cannot easily say without causing a package drop that you don't want more data. So receiver side, the optional to the optional thing. Yeah, so this is a messy thing on the receiver side, but it would be nice to have such a functionality as well. Yes, and as said, the optional things are optional, so we don't need to add them, but it would be cool if they would be in, of course. Yeah, any questions? Yes. Yes. Any other questions? The relay. Yes, I will need to look into it and try to fix it. Therefore, I would recommend you actually to really do the optional one thing. I should give them numbers, because then you can implement your whole client and test it with the TCP sockets that Qt provides. And are not reliant on the user mode TCP thing working correctly. Since we have, I think, at least 2 more lectures, we will have time to debug the thing to the end and make it working correctly. But if you do this, then it's then it will be also good. So if the user mode TCP is not working properly at the end, then if you have a working TCP implementation, then it's fine. And paradigms how this communication works for both is quite the same. So as you remember, we have examples on Moodle for networking just using TCP and connecting to a TCP socket. So you don't need to use the way Qt is doing this if you prefer the standard Windows way. But if you want, you can also connect with Qt. So I think the main advantage using Qt's method will be that you will not need a own worker thread when implementing the asynchronous operations, because Qt does everything asynchronously and you can just listen for the events. Yeah. And of course, if you start implementing those things now over the holidays, if you have questions about your individual implementation during the last 2 lectures next month, then you can ask them during the lecture as well. So you don't need to work on it and then hope for the best, but you can present how far you are already and how it is working. And if you have a problem somewhere, we can discuss them and try to debug them together during the next 2 lectures. Okay, any more questions? Okay, seems not. In this case, since we are 1 minute over time already, it's time to finish for today. And we will see each other sometime after the holidays. Let me see when. Yes, I think it's the 12th January, the next lecture. And then the 19th January, and I think the last one in the last month for and then the last one, the 26th, was not in the in the how is it called, Vorlesungsverzeichnis thingy. Let me quickly check this, because like they are selecting when they stop and when they start. Details. Yes, so it seems to go only to the 19th, but since we lost 1 lecture when I was sick last week, or 2 weeks ago actually, then if you want, we can put this day back in on the 26th, yes, of January. So that depends on your preference. If you prefer to take the time and work on the project on your own, that's also fine. But if you want, we can have a third lecture so that we don't lose any time. But I guess this is something we can decide on the 19th, depending how far you will be at this point with your project. Okay, any more questions? If not, then we are done for today. Okay, then bye bye. Ja, frohe Weihnachten. Ciao, ciao.